Okay, so I'm going to start my second session. In the second session, I have already told you that in the first session, I've already told you that uh, I gave you a problem where a general form of LPP was given to you, and that was transformed into a standard form of LPP, which is given, as you can see on the right-hand side of this whiteboard. Now, we have this standard form of LPP with us with some slack and surplus variables and artificial variables. I'm going to design a simplex table to solve the system. Now, first of all, you have to know what is the format of the simplex table. Okay, so let us try to write the format of the simplex table. And whenever I'm writing, I'll write a simplex table to solve a system. Every time I have to follow this particular format. Okay, so I can still see that there are 31 participants and 28 participants have written their roll numbers. Remaining 9 participants are not yet present. Please ask them to join. Okay, so simplex table is there. What is the format? Let us try to let me write the format first of all, and then I'll explain term by term. So we'll first write CJ. Okay, then here we shall write, just below that we shall write CB, B, and XB. These are the headings, column headings. And here we'll write minimum positive ratio XB by pivot column, XB by pivot column, pivot, P-I-V-O-T, pivot column. And below that, I'm going to write ZJ. And here I'm going to write ZJ minus CJ. This is the format of the simplex table. You have to memorize this format every time you draw the simplex table. Okay. How many rows are there? 1, 2, 3, 4. How many columns are there? 1, 2, 3, 4. Okay. Now, what are these things actually? Just beside XB, I'm going to put all the variables that are present in the standard form of the LPP. The variables are X, Y, S1, S2, A. I'm going to put them serially. So I'll first write X, then I will write Y, then I will write S1, S2, and A. Okay, that is the first part. What is CJ? CJ stands for per unit contribution of the variables in the objective function. Okay, so you already know that per unit contribution of the variable X in the objective function is 2, of the variable Y in the objective function is 3. This is 0, this is 0, and this is minus M. Okay, what is capital B? Capital B stands for basic variable. Okay, so what were my basic variables? My basic variables were S1 and capital A, if I can recall from my previous session. So I'm putting my basic variables as S1 and capital A. What is CB? CB stands for coefficient of basic variable. Coefficient of basic variable. So I'm writing here the coefficient of S1 is, as we can see, it is 0. And the coefficient of A, as we can see from the objective function, it is minus M. And what is XB? XB stands for value of the basic variable. Value of the basic variable. So the value of the basic variable S1 is 1 at present, and the value of the basic variable is 4. And here in this part, I'm going to write the coefficients of the variables present in the system. So the first row of table corresponds to first equation, and so second row corresponds to the second equation, and so on. If you interchange the equations, then your rows in the matrix will interchange. And we know that if the matrix is in the row and columns are interchanged in the matrix, the characteristic of the matrix is not affected. So if first row stands for the first equation, so we are going to write the coefficients over here. So the coefficient of x is 1, the coefficient of y is 1, coefficient of s is 1. Since S2 and A are not present here, so their coefficient is 0 and 0. And the second row corresponds to the second equation. The coefficient of x is 2, the coefficient of y is 2, the coefficient of S1 is not present, so its coefficient is 0. S2's coefficient is -1, and its coefficient is 1. So everything has been written accordingly. Now, these remaining two rows and one column, they are the part where we'll do some sort of calculation. Now, let me write the formula of ZJ. What is the formula of ZJ? ZJ is given by CB. If you call this CB as a matrix, if you look at this CB as a matrix, a column matrix, so it will be the transpose of this matrix CBT. That means the column matrix becomes the row matrix multiplied by variable xj. So to get the value of zj corresponding to this column, we shall multiply this matrix, considering them it to be a row matrix, by the column matrix of x. To get the value of zj over here, we are going to multiply this by column matrix 1, 2. To get the value of variable, the value of zj over here, we are going to multiply this column matrix, this row matrix corresponding to the column with by the column matrix 0, 1, like this. So, you know, I'm showing you one. For instance, if I want to calculate zj for this particular column, so what do I get? So z, we will call it as z1, because this is, or you can call it as zx. That will be cbt into x, and cbt is 0 minus, sorry, it is 0 minus m. It's a row matrix, 0 minus m. It will be multiplied by 1, 2, 1 and 2, column matrix 1, 2. So its multiplication will result in, what is the order of this matrix? First row, 1 row and 2 columns, 2 rows and 1 column. So the result which you will get will be a number. So it will be 0 into 1, 0 into 1 plus minus m into 2. So the answer will be minus twice m. Okay. So we are going to apply these things for all the columns. So we get 0 into 1 minus m into 2, that is minus twice m. 0 into 1 minus m into 2, that is also minus twice m. 0 into 1 minus m into 0, that is 0. 0 into 1, 0 minus m into minus 1, that is m. 0 into 0 minus m into 1, that is minus m. Okay. Now zj minus cj is straightforward. What I need to do is that from each of the values of zj, the corresponding value of cj will be subtracted. So we are going to write it over here. So for the first case, zj minus cj will be minus 2m minus 2. Okay. Second case, zj minus cj will be minus 2m minus 3. Third one will be 0 minus 0. Fourth one will be capital M minus 0. Last one will be minus M plus M, that is 0. So we have calculated all the things from here. Okay. Now what about the last one? Zj minus Cj. Now I shall come back to this particular table once again, but before that I need to write something. Okay, so I'm writing it over here so that the table will be in front of you. Now rule number one, let us call it rule number one. Rule number one says that if all the values present in Zj minus Cj are non-negative, that means they can be 0 or positive. If they are so, then we say that optimality of the system has reached. Optimality of the system has reached. Optimality of the system has reached. Okay. But if at least one of the values of Zj minus Cj is negative, we have to proceed with the construction of a new simplex table. Proceed with the construction of new simplex table. Now you see that this is 0, that is 0. Capital M is a positive quantity, as I discussed in the previous session. So we do not have any problem with this. But this quantity is obviously negative. Minus 2m minus 2 is obviously negative. Minus 2m minus 3 is obviously negative. So this particular table is not the optimal table. So we have to proceed further. How to proceed? How to proceed? If rule number 2, if the row Zj minus Cj contains more than one negative values, select the most negative number from them. Most negative number means, suppose we have minus 2 and minus 3. Which one is the most negative? I mean, which one is the most negative means who is lesser than minus 3 and minus 2? Minus 3 is lesser than minus 2. Minus 3 is less than minus 2. So minus 3 will be the most negative element. Okay, I'm just writing it over here for your clarification. So select the most negative number from them. The column under which this most negative number appears is called pivot column. Okay, it is called pivot column. After that, the basic variables values will be divided by will be divided by the corresponding values present in the pivot column. Okay, so let us try to do it first of all. Now we have these two numbers, -2m minus 2 and -2m minus 3. We will try to find out which of these two numbers is the most negative number. Okay, let us do it on the next page. So if I say, for example, I'm confused and I'm writing -2m minus 3 just arbitrarily, that -2m minus 3 is less than -2m minus 2. We will try to solve this system. If I do not get any absurdity, that means my assumption is right. -2m minus 3 and -2m minus 2. I can cancel -2m from both sides. And we get -3 less than -2, which is obvious. It is true. Okay, so therefore the most negative number in the table is -2m minus 3. So from the table, we find -2m minus 3 is the most negative number. And so column Y is the pivot column. Column Y is the pivot column. Okay. Column Y is the pivot column. So what is written over here? Minimum positive ratio XB will be divided by the pivot column. So this becomes my pivot column. Let us mark it. This becomes my pivot column. Okay. Now I'm going to divide each and every element of present in XB by corresponding value of the pivot column. So let us try to do it. So XB's first value of XB is 1. It will be divided by the pivot column value, which is 1, which is equal to 1. And second value is 4, which will be divided by the corresponding value of the pivot column, which is 2. The answer is 2. Remember that here it is written minimum positive ratio. So if in some problem, if you get negative ratio, that should not be considered. Or if you get something, say something divided by 0, then that cannot be calculated. So every ratio considered over here should be the positive ratio. Okay, so we have constructed it. Now, since we have found the pivot column, its dual is the pivot row. So how to find the pivot row? So it's rule number 3. After calculating the positive ratios, we find the minimum positive ratio from them. We find the minimum positive ratio from there. The row corresponding to which the minimum positive ratio appears is called the pivot row. Okay, so you see the minimum ratio in this particular case is this one. This is the minimum positive ratio, and therefore it corresponds to the row, this row. It corresponds to this row, and therefore this particular row will be called the pivot row. Okay. The intersection of pivot row and pivot column gives us pivot number. The intersection of pivot row and pivot column gives us pivot number. So my pivot number in this case is given to be this one. This one is my pivot number. Okay, this one is my pivot number. What is the objective of finding these pivot rows and pivot columns? The objective is that in my basic variable column, the variables S1 and A actually is not my original variable. They are not my original variables. We are not interested in finding their values. Our objective is to eliminate the unwanted variables from the chart and to get the variables which are wanted. Okay, so this basic variable column actually gives you the solution. This column is very important. This column is actually will give you the solution. This column will give you the solution. Okay, so we are interested in this particular column. So why am I calculating pivot row and pivot column? Because pivot column gives the entering variable in the basis of the new simplex table. Okay, and pivot row gives the departing variable from the basis, gives departing variable from the basis, departing variable from the basis. Okay, so my entering variable, new entering variable in the basis will be y, and departing variable will be s1. So in the new simplex table, y and s1, y will take the position of s1 and s1 will not be present. S1 will be eliminated from the chart. So I'm going to construct my new simplex table. And why have I calculated the pivot number? What is the relevance of this? I'm writing over here. Pivot number will help us to construct the new simplex table. The new simplex table. Pivot number will help us to construct new simplex table. So let us try to find out how to do it. I do not know what is the mental stage of the students of my class at this point, because you know how harder this particular methodology is. That now probably you are thinking that you will not be able to give the examination, CA1 examination on if I keep simplex method. I'm not going to ask harder questions. I'm going to ask only those questions which have been covered in the class for the CA1 examination. I can ask you points from the steps of the algorithm. Okay, so you have to attend the class properly. I know what I have taught you, and according to the question will be set, so don't worry about the question. Okay, learn the method, because in the main examination you have to deal with this, even if it is online examination, then also. So I'm in the next page, I'm going to show you how to construct the new simplex table. It is also very hectic for me because you see that you are learning it for the first time probably, but to discuss such a harder topic, it is also very much hectic for me because it is too difficult. First of all, I'm going to copy the variable, I'm going to copy the simplex table 1 on the left hand side, because since it is there in the another page, I think it should be in front of our eyes always, because if the first table is in front of your eyes, then you can construct very easily the second table. So I'm rewriting this once again. I'm rewriting this once again. Okay, so we have 0 S1 1. Okay, we have 0 S1 1, and we had 11100, 11100, and we have minus MA4. Okay, minus MA4, and that will be 220 minus 11. 220 minus 11. 220 minus 11. And ZJ minus CJ was minus 2M. Okay. I'm not copying that because it is not required at present. Okay. So I'm not copying ZJ minus CJ. Its objective is done. Okay. That was my first simplex table. And we know that this is my entering variable, and this is my departing variable, and this is my pivot. This is my pivot number that I know. Now, construction of the second simplex table. Let us try to do it. So I'm writing the format once again: CJ, CB, B, XB, minimum positive ratio, which is XB by pivot column. Okay, and we have ZJ minus CJ. Let us put all the variables as before: XY, S1, S2, and A. Put their per unit contribution, and capital A will not change its position. It will remain as it is. Correspondingly, its per unit contribution will be there, and S1 will be replaced by Y. So I'm putting Y, and since I'm putting Y in the basis, okay, so its per unit contribution is 3. So I'm writing 3 over here. What is the job of this pivot number? First of all, we are going to write that row in the new simplex table, which had pivot number in the preceding simplex table. What does it mean? It means that in the preceding simplex table, first row contained the pivot number. So in the new simplex table, I'm going to write the first row, first of all. Don't write the second row. In the previous simplex table, in the first row, pivot number appeared. Therefore, in the second row, you are first going to write the elements of the first row. And it is done in such a way so that pivot number becomes 1. That means what? Our pivot number is already 1. Now, suppose in a particular problem, your pivot number is 2. Okay, I can see that there are some people who are not attending the entire class, but just before the end of the class, they are joining in. I am noting everything down over there. Okay, anyways. So suppose in a particular problem, some element as the pivot number is not 1. Suppose here the pivot number is 2, and it is appearing in the first row. So in the second simplex table, I'll be writing the first row first in such a way so that 2 becomes 1. So in that case, I have to divide the entire row by 2, the pivot number. But here I'm not going to do that because it is already 1. So I'm going to copy it. You can say that I'm copying, or you can say that I'm dividing the original row by the pivot number 1. So it doesn't change actually. Okay. And this was the position of my pivot number, earlier pivot number. So I'm putting a star over here to mark it. That was the original position. The next row are calculated. The next rows are calculated in such a way so that below or above the pivot number, 0 appeared. 0 appears. Okay, so I have to apply sort of row operation over here. Now this is my new row. Remember, this is my new row. And that is my old row. I shall subtract new row from the old row. That is my row operation. I'll subtract the new row from the old row. And if I do so, what am I getting? Let us see. 4 minus 1, that is 3. 2 minus 1, that is 1. 2 minus 1, that is, no, one thing. I have to put 0 below the pivot number. So I am going to subtract new row from the old row in such a manner so that the 0 comes below the pivot number. So actually I'm going to subtract twice new row from the old row. So what am I getting? First of all, you try to multiply the entire row by 2. So what am I getting? I'm getting 2 here, 2 here. Okay, I'm getting 2 here, 2 and 0, 0. And then you subtract these rows from the old one. So 4 minus 2 gives you 2. 2 minus 2 gives you 0. 2 minus 2 gives you 0. And 0 minus 2 gives you minus 2. Minus 1 minus 0 gives you minus 1. And 1 minus 0 gives you 1. Okay, first of all, I'm multiplying the entire row by 2. So I'm getting 2, 2, 2, 2, 0, 0. And then I'm subtracting twice the new row from the old one. So I'm getting 4 minus 2, that is 2. 2 minus 2, that is 0. 0 minus 2, that is 1. 1 minus 2, that is 0. 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 1 2 minus 2, that is 0. So below the pivot number, 0 is coming. 0 minus 2, that is minus 2, minus 1, minus 0, that is minus 1, 1 minus 0, that is 1. Okay. And then as before, I'm going to find out the value of the ZJ. So it is 3 into 1, 3 into 1 plus minus m into 0, that is 3. This is 3 into 1 minus m into 0, that is 3. This is 3 into 1, and that is minus plus twice m. This is 3 into 0, and that is m. 3 into 0 minus m into minus 1, that is m. 3 into 0 minus m into 1, that is minus m. And correspondingly, the ZJ minus CJ will be 3 minus 2, that is 1. 3 minus 3, that is 0. 3 plus twice m minus 0, that is 3 plus twice m. M minus 0, that is m. Minus m, that is 0. Now you see, fortunate enough, we are fortunate enough that all the elements of ZJ minus CJ, all elements of ZJ minus CJ are non-negative. All are 0. So this table is my optimal simplex table. This table is my optimal simplex table. And what have we got from here? The solution is, since x is not present in the basis, so x is 0. Y is present in the basis, so y is 3. So we have got the values of x and y. But S1 is not present, so it is 0. S2 is not present, so it is 0. And artificial variable is present with the value 2. But as I told you earlier, if artificial variable is present in the optimal table, the solution is not actually, the solution is infeasible. We have got the optimal table, but we are not able to eliminate artificial variable from here. Artificial variable is still present, and therefore this system which we started with has infeasible solution. It directly correlates with the result which we obtained by the graphical method. Less than 1 minute is there. Once the class ends, after that you please rejoin once again. I'm stopping the recording over here.